All right, so here's your lesson for function properties or describing functions. This PDF is linked in Canvas, so if it's something that you think that you'd like to print out and sort of write all over and color all over like I'm about to, then you have the opportunity to do that. So first of all, I'm just going to add arrows on this to make this a continuous function. And I'm just going to go through and go over all of these vocabulary words and what they mean. So first of all, x-intercepts shouldn't be anything new for you. X-intercepts is where the function crosses the x-axis. So it happens 4 times for this particular function. X-intercepts can also be called roots or zeros. The y-intercept, we'll do this in another color. The y-intercept is where the function crosses the y-axis. You'll notice that there are multiple x-intercepts, but only one y-intercept. If we had more than one y-intercept, that would sort of violate our rules of calling this a function, and we wouldn't be able to describe it using any kind of function notation. So I will erase sort of what we have here so I can continue moving forward. Decreasing. So when we look at my function, we sort of describe this in different chunks. And we always want to scan with our eye the function sort of from left to right. So let's sort of make this blank grid here. And I want to look at my function, and as I pull this away, it looks like my y values are getting smaller, which is telling me that this piece of my function up until this point is decreasing. So I know that my function is decreasing for x values that are less than, let's see what x value this is. For x values that are less than -1, 2, x values that are less than -3, my function is decreasing. So now, as I continue to pull this sort of transparent rectangle away, it looks like as I move in this direction, my y values are getting larger up until this point right here. So I know that here, my function is increasing up until this point right here. So for x values that are in between -3 and 1, 2, and +3, my function is increasing. And then it looks like here we go back to decreasing from +3. So then my graph is decreasing again for x values from 3, 4, 5, and 6. So from 3 to 6. And then I'm increasing again. Let's use the same color blue in this section of my graph. So increasing again for x values that are greater than 6. So these are the increasing and decreasing regions of my graph. When I'm talking about the relative maximum and relative minimum, let's just go ahead and get rid of some of these, some of our scribbles. When I'm talking about the relative maximum and the relative minimum, the relative maximum of my graph, if you look, I have these arrows here, which means that my graph is going to continue to go up and up and up forever and ever and ever. So the relative maximum, we focus on the word relative. Sometimes you'll see that this is also called a local maximum. So the relative or local maximum is picking a local spot, just looking for the tops of mountains here. So this here would be a relative or a local maximum. Moving forward with describing my function and focusing on relative minimum, again relative but also sometimes called a local minimum. If the relative maximum is sort of the tops of these mountains here, the relative or local minimum will be the bottoms of these valleys here. So here and here we have relative minimum. And the way that we would describe this is we would say that there's a relative minimum that is located at -1, -1, 2, 3, -4, and another one that's located at 1, 2, 3, 4, 5, 6 at 6, comma, -1, and my relative maximum here is located at 3, 4. So we've covered x-intercepts, y-intercepts, where the function is increasing, where it's decreasing, relative maximum, and relative minimum. So now we'll chat quickly about end behavior. And so we'll get rid of those. I think this was here, -1, great. And I can go back in for end behavior purposes and stick my arrows back on. So end behavior always starts the same way. So we'll write this in red so we can see it. So it always starts as x approaches infinity, y approaches something. And as x approaches -infinity, y approaches something. So as x approaches infinity means as my x values are getting larger and I'm looking at my graph in this direction. So I'm looking at my graph going towards the right where my x values are getting larger. What's happening to my y values? And I can see here that my y values are going up, which means that they're approaching infinity. So for the first part of this function notation for end behavior, we would read as x approaches infinity, y approaches infinity. The second part is as x approaches -infinity, or in reading words, as my x values are getting smaller. So now I'm looking at my graph in this direction. So I'm looking as my x values get negative, and I can see here that my graph or my function is still going up. So as x approaches -infinity, y is also approaching infinity. So there's my end behavior. I have 2 vocab words left, positive and negative. And positive is where my graph is above the x-axis, and negative is where my graph is below the x-axis. So I'm going to go ahead and clear some of what we have here, and I can see that my graph is negative. Actually, you know what? This might be a little bit easier. That my graph is negative here and here. So here are the sections where my graph is negative, and that my graph is positive here and here and here. So if I were to describe that using appropriate notation, we always use our x values when we're describing, so I'll go ahead and label sort of my cutoff points. So this here is -3, this is at +1, this is at 2, 3, 4, this is at 5, and this is at 7. So I could say that my graph is positive for x values that are less than -3. My graph is also positive for x values that are in between 1 and 5. And my graph is again positive for x values that are greater than 7. So my graph is negative sort of all of the other times. So my graph is negative for x values that are in between -3 and +1. My graph is also negative for x values that are in between 5 and +7. So you'll notice that your assignment is really just taking this and describing lots of functions, making sure that we're using the appropriate notation as we do so. I think sometimes the trickiest notation happens to fall within this end behavior, so let's just make sure that we're doing that correctly.